Okay, hello and welcome back. This is Ahmed for Avionics, and this is the first section in your course, Mastering Docker. We have seen in the previous lecture the different software development approaches, the waterfall and the agile development approach, and we said that we are interested in this course in the agile development approach, and we said that in the agile development process, multiple iterations of the software build is made through the shortest possible time frame, like a couple of weeks, for example. So this needs an infrastructure that can adapt for such quick changes. As you can see in a typical iteration, each iteration may have some changes and it may have some tests. So those tests must be done on multiple environments. So these tests must be done on several environments. And as more and more iterations are made, more and more environments are needed. So that's why we need an infrastructure that can adapt for that agile development behavior. And in the previous lecture, we have said that virtualization has shortened a lot the time needed to set up a new machine than, of course, using a hardware machine. But that still was not enough. Developers needed a much quicker way of setting up new machines. So this is where cloud computing came into play. And to fully understand cloud computing, let's take an example. Let's say you are a web developer building a web application for a customer. You need a web server equipped with all your requisites, like for example Apache, MySQL database engine, PHP 5.5 and other libraries that you're going to need for your project. In a traditional model, you or whoever the responsible team will have to do the following. Assuming that the host machine or the hypervisor is already set up and purchased, the team will create a new virtual machine with the required resources, install the operating system, configure the necessary security and create the appropriate user accounts, install Apache, MySQL, and PHP 5.5 and any other runtime libraries needed, then start deploying your application. Should you need a new environment for example, another test or another iteration, you will have to repeat the previous steps or ask the responsible team to do so. Moreover, if you need more CPU and memory to run a particular test for a specific period of time, this will be a lengthy process that will incur a downtime. So let's say, for example, that you want to make a stress test on your application. You want multiple users, or you want to simulate that multiple users are accessing the application at the same time, and you want to see whether or not the application with the current configuration, with the current build characteristics, will hold or will crash. So you need some more CPU and more memory to do this test, but you're going to need those resources just for a period of time, a specific period of time, say a couple of hours, after which you no longer need those resources. You will have to ask the system administrator team or the operations team to shut down the machine, increase the memory, increase the CPU, and then start the machine back when you can make the stress test on your application. Then again, asks them to shut down the machine, get rid of the unneeded resources and like the memory and CPU, and release them back to the pool so that they can be used by other machines, and start the machine back up. This not only incurs a downtime that happens twice, but also it takes time. And as we said, in agile development, time is the most important thing. You must do the iteration in the shortest time possible in order to quickly acquire any changes and start the next iteration. If you are using the cloud computing way, this will be a lot different. In a cloud computing environment, you don't even have to purchase the hardware on which you're going to work. All what you have to do is set up an account on one of the cloud computing vendors, like for example Amazon AWS, Google Apps, or others, and choose the model that best suits you. And cloud computing currently supports three models: Infrastructure as a Service, or IaaS, Platform as a Service, or PaaS, or Software as a Service, or SaaS. We're going to have a look at the three models in the next slide. But once you chose a model, setting up the machine, it becomes as easy as making a few mouse clicks, and it takes minutes instead of hours or days to set up a machine than in the traditional model. You can also host your own cloud environment, and that depends on the scope of your application and the amount of budget that your company is allocating for that project. In all cases, development speed is increased, and this of course nicely fits the agile model. Now, let's have a look at the three types of cloud computing, or the three models of cloud computing. They are depicted in this graph or this table. Now, in a non-cloud environment, in a normal or virtualized environment, let's say, you are in charge of obtaining the hardware, the server itself, configure its networking, storage, different hardware devices like, for example, PCI cards and so on. You'll have to install the firmware on the hypervisor. Then you're going to start building virtual machines for the developers to work on. After which you will have to install the prerequisites like the database. You'll have to take care of the security, create the necessary users, install the necessary patches, and so on. Then you're going to install any runtime environments, like for example PHP or glibc libraries, and finally you deploy the application for the developer to start working. If you are using a cloud service, you can apply for an infrastructure as a service model in which networking, storage, hardware, and hypervisor are all managed by the vendor. They are not managed by you or the developer, because in this case the developer himself can create an account and start using the machine right away. So the vendor here is in charge of the lower level infrastructure, and the user, whether it was the developer or the system administrator, will just start creating a virtual machine out of the hardware that is managed by the vendor. So you create the virtual machine, the database, take care of the security, install runtime libraries, and then deploy the application. The next model is Platform as a Service, or PaaS, where not only networking, storage, hardware, and hypervisor are taken care of by the vendor, but also the virtual machine itself with all its prerequisites for deploying the application, like the database, security patches, security users, runtime environment, and so on. So this is a model that will be suited specifically for the application you are trying to deploy. You just choose those settings and start the machine, and the machine will start pre-deployed with all the prerequisites you will need to deploy and start using the application or testing the application. And finally, Software as a Service, or SaaS, where all those components are handled by the vendor. You don't handle anything except testing the application itself. So even the application in this model is pre-installed on the machine. So you just log in to the application itself. You don't even need to log into the machine. Just log into the application and start testing the application in that environment. So as you can see here, cloud computing saved a lot of time and a lot of costs than using the traditional non-cloud model. So where does DevOps fit in? Since the start of this section, and this section was titled An Introduction to DevOps, but we didn't actually talk about DevOps yet. Well, that is because DevOps is the second step after cloud computing. It is the next step that further reduces the time needed to make the software iteration or the software build iteration as short as possible. DevOps as a word is the combination between development and operations. Development implies software developers, and operations implies other IT departments like system administration, quality assurance, and so on. So both of those teams get bundled together in one team that is called the DevOps team. DevOps complements cloud computing and the agile development model, of course, because it aims at facilitating and thus shortening the application lifecycle by automating the delivery and infrastructure changes. It's all about automation. DevOps is all about automating mundane tasks that can be automated. Anything that can be automated must be automated, and that is the essence of DevOps. So before DevOps, as we have seen, communication between functionally separated organizations was more difficult and time-consuming. So as we have seen in the previous lecture, when the developer team needed a new environment, they have to ask the operations team or the system administration team to create that new machine. So this not only puts a headache or an extra work on the operations team, which are busy trying to make sure that everything is working and is continually working, monitoring the already running machines and doing other tasks. This puts an extra overhead over those operations team. And of course, because they are already busy doing other things, this will make deploying new environments for the developer team require more time. And as we said previously, the agile development approach is all about shortening the time needed to make a software iteration and delivering the software product, even in its most basic form, as quickly as possible. And that brings us to the end of this lecture. My name is Ahmed, and see you next.